At Amazon, you want to work with us at Voice First, you want to work at Facebook, Amazon, Netflix, Google, or any other tech company, it's always good to practice algorithms to keep your skills up to date and also just push yourself to lean into fear. Try new things that you've never tried before. Experience hardships you've never thought of. Solve new algorithms. LeetCode is the site that we go to, https://leetcode.com. They have lots of algorithms. You can sort them by difficulty. We're just starting off with the easy ones and we're working through. Just giving them a shot. Really just the practice is more important than what it is that you actually do with it. As long as you're setting time aside and you're practicing your algorithms, I think that's one of the most important things you can do. We'll try this next one, toLowerCase, to see how difficult it is. We solve most of our algorithms with Java. We have made that pretty clear because it's what they teach us in school. In most of the professional work we do at Voice First, we've used JavaScript, but sticking with Java for the programming helps to reinforce a lot of the people who are both watching the video and helping us with the algorithms. So, we have to create the toLowerCase function. All that happens is they pass in a string, and then we have to return the same string lowercase. Seems pretty straightforward. That seems really straightforward. So to start this off, I'm going to copy this code over. Let's create a new file. New file called toLowerCase. New file toLowerCase.java. So now we've got a Java file for our toLowerCase, and really simple description. This is it. Don't close that.
Why would we do a recursive, right?
Ooh, there you go. Now you're thinking.
Just do it iteratively. It's easier. Yeah,
It is an easy one. Yes, it is an easy one. That's another thing to consider. Is maybe recursion is too hard of a concept for an easy level algorithm.
But isn't it better to learn on an easy algorithm than?
There is such a thing as over-engineering, but you could also be right. So explain your thinking some more, Samir.
Like recursion is it's a concept that requires a lot of thinking but if you get it, it's great. So you want to start off with something easy so that you actually build a sort of a building block or a base for recursion.
Let's type out high-level thinking. Yusuf, you start thinking about how you would think high-level, like don't think actual code, just like actions that you would take in an algorithm to do it without recursion. Samir, you start telling me. I'm going to type some comments for recursion. So for recursion, what do you think? What would we do? High level.
We need a base case first.
Base case. What is it?
If length is 0.
Okay, what's next?
Yeah.
Oh, 0 or 1.
Okay, yeah, thanks.
And then if it's not 0, then we just.
Oh yeah, because you have the empty string. Okay.
Wait, what?
If it's not 0, then you just take off the letter and then you call the rest of the case.
Yeah.
If not 0, do what? One step at a time.
Not 0, you take off the first letter.
Take off first letter. Okay, then what?
And then, convert it to lowercase.
Convert first letter to lowercase.
Oh, and what's great is that the character class has a method to convert it to lowercase.
But that is toLowerCase.
No, this is string to lowercase. We might be able to use the character to lowercase. Not important right now. Right now we're thinking higher level. What comes after we convert that first letter to lowercase?
Then you pass the rest of it into the function.
Okay, then what?
And don't you just concatenate it?
Yeah.
Concat what?
The first letter with the first function.
To return value.
Yeah.
Then what?
That's it.
Yeah, that's basically it.
That's all it is.
Spot on.
We do got to return some at some point, so we'll return
Just
return concat, return string, yeah, return string. All right, so this is a recursive solution. Yusuf, you have now had time to think of your implementation.
Okay.
What does that look like?
So basically loop through every character.
I like it.
If the character is uppercase, make it lowercase.
Mm.
Otherwise, oh wait, shoot, they're immutable type.
I was just going to ask you that. Are strings mutable or immutable?
Okay, so yeah, they're immutable. Create an empty string.
Nice. There we go.
Loop through every character in str.
Nice.
If that character is uppercase, or just even add the lowercase version of letter to the string created and repeat it. So to the string created and go to next character.
I like this. Maybe we can see what both solutions look like, which one's easier for us to create, and then if we get them both to work, which one has a faster runtime. Only one way to find out.
They're both linear, right?
Yeah.
I don't know. Okay. Cool, so we've got two different use cases. Let's read. Can you talk us through yours real quick, Yusuf? I didn't hear it the whole way.
Sure. So first we would say something like string to return.
Oh, you're already going. Cool.
The empty string, and then while
Don't mind me.
actually, not while, for index equal 0. Index is less than
str.length, yeah.
Index plus plus.
Nice.
Then you have string to return. Plus
This is pair
equals-
programming at work.
Actually, wait. We said we were concerned about runtime, right?
You do your thing. Yeah, you just keep going.
Because I was saying if we're concerned about runtime, it would be better to get a string helper instead of instantiating a string, since it's just more costly to do the plus equals. But for no worry about runtime, you just.
Do you want to start typing out the recursive version?
Yeah, I'm not very good at recursion. That's why I wanted to do recursion. Yeah.
Cool. Perfect time for you to. Yeah, you're right. Then perfect time for you to practice.
Plus equals, what is it? String.
I'm gonna resume the music. Did you stop it or did the album end?
I think the album ended.
Alexa, resume music.
Index to lowercase.
Nice.
And then you just return that string.
Okay, let's.
Okay,
This is probably the whole solution. Let's see if it works. That was fast. Which it is an easy one, so hopefully it is this easy. Let's run it.
Java does a lot of nice stuff for you.
Womp womp. Let's see what the problem is.
Oh, string to
I don't think it likes that we're combining the stuff.
STR. No. Yeah. That's right.
STR.
So we're trying, the function we're working on tonight is just two lowercase. Take a string and then make all the characters lowercase. Samir wanted to try a recursive version, and Yusuf did not think that was worthwhile. So we have an iterative version going as well as a recursive.
In C++, could you just subtract the ASCII number of whatever?
You want to do a C version, and then we got 3 versions of this going?
Well, I think you could do what you're thinking about. I think you could do either way. But what if the character is uppercase and we subtract that? Then it's not even a letter at all. Oh, I'm sorry. So not add to get to lowercase. Add to get to lowercase. Well, if it's a lowercase in that case, then you're not even doing the letters. So
Don't add if it's lower.
Yeah, don't add.
Check if it's a lowercase, and if it's a lower, don't add anything.
Yeah.
So is your solution good to try again?
yeah, the solution is good to try again.
Thank you.
So how do you do this in Java?
Well, we outlined it first. So the first thing we did is we created comments of high level what it is we want to do. So for Yusuf, you wanna talk it through while I'm running?
Yeah. So.
I think it doesn't like that we're compounding char at and toLowerCase. I think we want to create a character first to hold this string.char at, and then make that toLowerCase.
Let me see what char at.
Yeah.
Let me see what toLowerCase
Does.
really.
So for use of solution, the iterative solution, what we do is we first start by creating an empty string to hold our return value. Then we loop through every single character in that string. So start with index 0, while it's less than string, index plus plus. Then we just add the lowercase version of the letter to the string created. So we take the current character, index, we make it lowercase, and then we add it to the string that we want to return. And then loop through, do all that, and then return the value. No, now you definitely have a recursive function.
What happens?
Is that a string function? It's lowercase?
Yeah.
Oh wait, but then we have it locally.
You can do it here, that,
Yeah.
and lowercase.
Okay, yeah, because we have a locally defined. Okay. Yeah. So that's why it's
How we doing, Samir?
is that
I'm taking.
Okay.
Are you good with recursive calls?
So if string length is 0, return value?
Yeah, which is just an empty string.
I think you mean
okay.
return value.
No, we don't have to do return.
What is this statement mean right here?
here?
Oh, you get return value is equal to empty string. I guess we can do it that way.
There we
Do
go.
what?
Do a return value at the end.
I don't think I understand what the purpose of this is.
Oh, and by the way,
Just for the basic thing.
yes.
What-
Yeah,
what-
that's basically how you would
what-
implement the toLowerCase.
What does this do? Does it even compile?
It's just that,
Sure.
like, in
Why?
Java,
Like,
we
this is just a
consider
word,
that
a variable.
Yeah.
Right.
Okay,
Return
okay.
that variable.
Let's see if it
Right, I
compiles.
didn't have a return statement.
So yeah.
Let's see if it compiles.
C and C++, that's exactly what
What?
you do. Yeah,
It does not. It's not a statement. Yeah, that's what dude. This isn't a statement.
No, now try it.
Yeah, it's saying that it has a problem with this. This is not a statement. In code, you cannot just have a single variable name.
You could-
Yeah, even with your return statement, it still doesn't like the fact that you just have a word there.
Okay.
Are we good now, Yusuf?
Yeah.
What did we change?
Actually, no, we're not good now. Okay, so there we go. So now we're good. We basically changed, we're accessing the character method to lowercase, the character class.
Nice.
Instead of the string class.
Nice. Okay, let's run this guy and see if we're still dereferencing stuff. Hey! Alright, so now we finished. Let's see if it submits. Alright, so completion-wise, Yusuf was able to come out faster.
All right.
Yusuf was able to come out faster than the recursive solution. So, just off of time to completion, iterative was faster. Samir is still working on recursive.
Yeah, I'm bad at recursion, that's why.
Cool, so we have one working
So
solution.
wait. So
Valid!
So it's true.
Nice work, Yusuf. Did I spell your name right?
Yeah.
Capital Y though. 100% of other stuff.
Do we need this stuff? We don't need this LCM.
And we are even using very little memory too. Whoop! Alright, so now we just have to work through the recursive one. So, instinctively not feeling like the fastest choice, but I guess we can't judge it until we're done. If string.length equals 1, return value equals string.char at 0. Okay. Else. Is there a reason you have else on the next line instead of?
Yeah.
There is?
Yeah. I have to write the else.
Yeah, but any reason it's there rather than here?
No.
Okay. If it's not there, what we want to do, so let's keep with these comments. If not 0, take the first letter off. So char first letter equals string.char at 0. Where? Chat. Thank you. Thank you. Char at 0. Next part of your algorithm is we take this. Like your comments make it easy. I think you're overthinking it, trying to figure out how the recursion works, but you've already defined it up here. So convert the first letter to lowercase, so we can take what Yusuf did, and we can character dot lowercase first letter, and then we can assign this back to first letter. Okay, next pass the rest. You want to keep doing this? Like, did I break down the wall, or are you still having trouble with this, Samir?
No, I'm still thinking.
Pass the rest of the string into the recursive function. So we do want to make a substring here. That's one thing we forgot to define, is that we want a substring. Create substring.
I think you guys make the recursive solution much more complicated.
Yeah, that's what I was thinking. Do we even need to declare a char?
I'm just following the string rest of a recursive string equals tr dot sub string from 1. That should give us the rest of it. Okay, so now we have a substring, and now we want to pass the rest of the string into the recursive function. So toLowerCase, pass in recursive string.
Also, toLowerCase that goes with both.
Are you talking about this call?
Yeah.
Yeah. This call is part of the character library in Java. Okay, now we want to concat the first letter to the appended value, or to the return value. So we want to assign this to string. We already have it. So returned value plus equals, and I think we can even say returned value plus equals that. Return value plus equals toLowerCase, rest of the string. Concat the first letter to the return value. We do that up there, so we can get rid of that. And now we return returned value. I'm going to refactor this to final string. Nope, just this guy. Okay, let's see if you work. Recursive function, first attempt. I think it took 3 attempts, maybe 4, to get the iterative solution working. We expected a semicolon, and I was dumb and did not include a semicolon. Let's see if I can get it this time. Alright, char cannot be dereferenced. Yes, we are using the wrong kind of toLowerCase. Final string, what? What do you... you didn't use the same thing that Yusuf had used. Alright, we'll try it again. First one was one of the same problems that Yusuf had, so regardless of whether it was recursive or iterative, we both did the wrong form of toLowerCase. Char cannot be converted to string. Alright, so the difference here is that we've gotten string.char at 0. I think we want to define it as the same thing. And now up here we'll go first letter. We'll save this, we'll try it again. Did someone put this here?
I put that there.
You want it there?
Yeah.
Okay.
Yeah.
Just looks good. Just want...
Yeah, it's just like one return statement.
Char cannot be converted to string.
Recursive does not seem to be working.
There's something different about these two calls. because it works down here.
So final string is a char.
Final string is a string.
Try it now, see.
Oh,
Try it now. We've changed it from equals to plus equals. Let's run that. And we now have a successful output. Let's see what happens when we submit the guy. We get a successful output with the exact same runtime, much higher memory usage. So we have we're in the 10th percentile of memory usage for the recursive version, whereas the iterative version we're in the like 80th or 30th percentile. So we're not very high in either of their memory usages for either version, but the iterative solution did seem to take less time, is less lines of code, and save memory over the recursive solution. All right, so thoughts. Having run both of these and they both work now, what are your thoughts on recursive versus
I still hate recursion.
iterative?
I think this is like a bad example of where like recursion can be used. Usually like recursion is used on more complicated examples that just like iteration would just be extremely useful. Like trees. Trees are extremely good for recursion, but they absolutely suck with iteration. So that's like a better example.
Yep.
Of
Iterative problems.
Yeah.
So this is all going onto the GitHub repository so that other people can see it. Recursion should not be used for iterative problems.
I mean, technically all recursive problems are also iterative problems.
Yeah.
But
Recursion
there are like some moments
takes
where
more memory than iteration on this. Recursion is good for complex problems. EX trees. Any other examples? Maps?
Oh, maps.
I don't know.
Mostly trees.
Yeah,
Yeah,
trees.
There's some hero of recursion.
Okay, so trees. EX trees. Cool.
It's a class in software 1, which is called natural number, is also really good for when using recursion line.
Just do a little bit of formatting and then we'll call this a day. Didn't take us super long. It's always nice when it doesn't take us super long. We've finished consistently. Maybe we should start moving up to medium, or
That's what I was thinking.
do we like having the ability to solve it?
No, that was like
Chump change.
Chump change.
We're now no longer even working on the same problem. We're now like dividing up work and testing recursion versus iteration. Because these problems are so easy for us. Okay. So, clear cd tilde / projects algorithms ls clear git status git pull origin master git checkout -b feature / toLowerCase git status git add toLowerCase git commit -m. I add the iterative and recursive solutions to the LeetCode problem toLowerCase. Git push origin feature / toLowerCase. Screw your passwords. I hate this part. I never remember what my passwords are. I need to just set up an SSH key with GitHub real quick. Maybe there's a good time to do that. No, I don't want to show an SSH key. I just need my phone to get the password. Bigelow. Alright, let's find GitHub password. For everybody that's watching the stream, go ahead and have fun looking at this screen for a little bit while I'm finding the passcode. Actually, what's something better we could show? I don't know. In the meantime, watch this galaxy.
Black hole.
Oh, there we go. Black hole. Black hole hour video. Nope.
Oh, black hole.
That's white noise.
It's white noise. Nope. Nope, I think black hole was the wrong move, not finding anything. Galaxy hour video. There we go. Enjoy while I find the password. Alright, we want... Alright, I think I found one. Success. All right. GitHub. This is probably taking longer than the actual algorithm itself. Sign out of that repository. Universe is pretty when you put filters on it. Like, what thing looks like that to human eyes? I don't think anything. You need a filter. But does not detract from the beauty. Alright, go back to repos. Algorithms. Compare and pull. Create pull request. After you create a pull request, someone's got to close the pull request. How do we, the branch has no conflicts. Pull requests, who needs to merge it? Who merges these? I thought I could merge them. Maybe only Sweetman Tech can merge them. Okay, I'll sign into Sweetman Tech. Or we just create a different pull request that's not to the Sweetman Tech branch. I don't know why I created it to the Sweetman Tech branch. Probably because I wasn't paying attention. We don't need to merge it to Sweetman Tech. We will, instead of Sweetman Tech, Voice First Tech. There we go. Create that pull request. And now we can merge. Bam. Merge that. Now we close the loop by get checkout master. And we get pull origin master. We've got the updated version of the code, and that is it. Thank you everybody for joining us. That's another LeetCode algorithm session. We'll catch you next week.